Udah ada belum sekarang?
Nah,
Udah kayak.
sip, udah ada.
Oke, KSP boleh dibuka.
Starting.
Udah kayak.
Sip, udah ada. Starting. Ini masih sepi kayaknya. Tunggu beberapa menit dulu paling. Oke. Saya buka aja. Assalamualaikum warahmatullahi wabarakatuh. Selamat malam teman-teman. Mungkin kita perkenalan dulu ya. Ini perkenalkan, saya Espin dan teman saya Sartika. Ini Meetup Bogor Kubernetes Cloud Native yang pertama. Jadi kita nambah daerah lagi yang Bogor, dan ini Meetup pertama kita. Terus juga terima kasih untuk Mas Giri selaku CNCF Ambassador karena telah membantu pembentukan Kubernetes Cloud Native Bogor. Harapannya semoga Meetup Bogor selanjutnya bisa dilaksanakan secara offline dan kita dapat saling bersilaturahmi satu sama lain. Dan semoga pandemi ini cepat berakhir. Mungkin bisa dilanjut lagi ke Sartika.
Oke, makasih Kak Espin. Semuanya teman-teman salam kenal. Kayak yang tadi udah Kak Espin bilang, saya Tika dari co-organizer-nya Cloud Native Bogor, bantuin Kak Espin untuk manage organisasi ini. Baiknya kita langsung lanjut aja untuk mempersingkat waktu. Selamat malam semuanya. Agenda kita hari ini yang pertama, kayak di meetup biasanya, ada Kubernetes Community Update, terus dilanjut sama ada talk pertama dari Srinivasa Vasu, Field Engineer dari VMware, terus talk kedua ada Mas Ausafi Setiawan dari PT Infracom, selaku Solution Engineer, dan yang terakhir akan ada announcement selanjutnya. Hari ini openingnya First Kubernetes Cloud Native Bogor Meetup, online Meetup, udah ada di platform Cloud Native Community di chapternya Bogor Asia. Boleh gabung yang warga Bogor sekitarnya. Terus next ada previous meetups. Ini isinya tentang meetup sebelumnya. Materi-materinya sudah diupdate di GitHub-nya. Next, ada update dari Kubernetes Cloud Native Indonesia komunitas sendiri. Update-nya itu ada meetup terakhir yang kemarin itu yang edisi Hacktoberfest. Ada Prometheus yang kemarin. Next, Cloud Native ada buka Steam baru untuk meetup. Ini teman-teman semua yang punya personal project tentang open source yang berkaitan tentang CNCF project dan lain sebagainya, bisa nih submit untuk videonya. Barangkali mungkin masih malu untuk talk durasi 30-40 menit, bisa untuk submit videonya dengan durasi 5-10 menit. Nanti ini bisa diklik submit here, nanti akan dibagikan slide-nya. Terus ada CNCF events yang upcoming itu ada yang di bulan Desember, nanti ada open source summit, sama ada KubeCon Europe 2021 itu udah buka CFP submitnya. Mungkin teman-teman ada yang mau nyoba submit CFP, terus nanti bisa konsultasi di grup Cloud Native Indonesia gimana sih supaya CFP-nya bisa keterima di conference-nya Kube. Next, ada update terbaru itu ada Kubernetes buat sertifikasi, itu ada yang untuk spesialis security dengan syarat yang mau enroll CKS ini harus sudah CKA dulu karena fokusnya di security-nya Kubernetes. Nanti bisa dilihat ini juga udah di-link ke website-nya untuk CKS ini lebih lanjut. Next, ada updatean CNCF survey yang 2020. Dari datanya ada 92% dari production yang menggunakan container. Ini naik 300% dari bulan Maret 2016 itu yang survei pertama. Yang cuma 23%, sekarang udah ada 92% dari production yang pakai container. Terus ada 91% yang pakai Kubernetes, dengan 83%-nya itu pakai di production dan naik dari di tahun sebelumnya itu 78%. Terus sebenarnya kurang dari sepertiga, sekitar 30% dari yang submit survei ini pakai serverless di production, dengan 21%-nya itu lagi mengevaluasi penggunaan serverless dan 14%-nya itu lagi merencanakan untuk penggunaan serverless di 12 bulan ke depan. Talk pertama ini dari Srinivasa Vasu akan membicarakan tentang code to production ready container with Cloud Native Buildpacks. Talknya dalam bahasa Inggris. Untuk teman-teman yang mungkin nanti akan ada yang mau ditanyakan, bisa diketik aja di kolom komentar dalam bahasa Indonesia maupun bahasa Inggris. Nanti kita akan membantu translate apabila itu dalam bahasa Inggris. Oke. Okay, Srini, are you ready?
Yep.
Okay, please, Srini.
Are you able to see my screen? Can you guys see my screen? All good? All right. Good evening, everyone. I hope everyone is staying safe and healthy. First of all, really appreciate the passion and the energy that the community members and the organizers carry in successfully running this event every month. You guys are doing a tremendous job. Keep up the good work. Kudos to the entire team. Happy to be back for the second time again. I did a talk on cluster APIs a couple of months ago. Good to be back again. My name is Srinivasa Vasu. I'm a solution engineer with VMware. And today's talk is on Cloud Native Buildpacks. So before we get started, please keep your questions coming in the chat window. I've got 30 to 35 minutes. If time permits, I'll try to go through your questions online. If not, I'll answer as much as I can via the chat channel, right? Again, congratulations to CNB Cloud Native Buildpacks contributors and the community team. it's a CNCF incubated project now. So it graduated from sandbox to incubation. That got announced in the recently concluded Cloud Native and KubeCon event. So let's dive into the session. What's Cloud Native Buildpacks? It transforms your application source code into a runnable artifacts, right? So the craft of producing a runnable artifact from a source code isn't nothing new, right? So Buildback as a technology has been in existence for quite a number of years now. Heroku invented it way back in 2011, and then Cloud Foundry community adopted it, and then they took it to a lot of enterprises, right? So back then, there was no clear specification around this Buildback. What happened was Heroku ended up having their own implementation of Buildback, and so is Cloud Foundry as well. The Buildback as a technology was tightly coupled to the underlying platform. If you look at the Cloud Foundry platform, a larger part of the developer experience that you get with Cloud Foundry is built around Buildback. But if you really want to run Buildback as a technology outside of the platform, that was not really easy. It was impossible because it was tightly designed for the underlying platform. Fast forward to 2018 with the emergence and the maturity of container technology space, and the associated tool sets have enabled folks from Heroku and Pivotal to come together to bring the best of both worlds to a new unified convergence spec, if I had to put it that way, the version 3 specification of Buildpacks called Cloud Native Buildpacks, right? So what does it do? Let's dissect. I mean, as we move on, let's try to understand what is this initiative all about, what does it do, and how it's helping developers and operations of the industry, right? What problem does CNB solve today? We understand that the application architectures are changing. We are moving away from monolithic-based architecture to a microservices-based architecture, mainly to solve the people and team scalability problem more than a technology problem. So what we have started to see is more about the destiny of these services is controlled by the team that builds it. So it goes with the notion of you build it and you own it, right? What used to be a single monolithic-based application, it's been broken down into multiple services. And since these teams are owning these services, they have the luxury and flexibility in terms of picking the right language on time, picking the right set of frameworks that address the given set of business requirements, right? So a single service is being broken down into multiple different services being built using different languages and different frameworks. Now, the next obvious question is, how can we package and distribute these apps, right? Packaging a single application itself is not an easy thing. We have to look after so many things. Now, the same thing is being kind of extrapolated into multiple folds in terms of the number of languages and frameworks that you deal with. And containers have become the de facto standard packaging format. So the obvious choice is to go with containers, start writing your own Dockerfile, right? So this is something that every developer would have seen it in the past, or every developer would have tried it themselves at some point of time, writing their own version of Dockerfiles. So Dockerfiles are great. It gives you a lot of flexibility. It's a kind of double-edged sword, right? So you would be able to do a lot of things with Dockerfiles, but at the same time, as developers running a production-grade, secure, hardened, Dockerfiles are not really easy, right? So it's very, very complex. It's complicated, time-consuming, and it's operationally very intensive as well. And then, as you know, as you know, Dockerfiles are really composed of multiple layers, right? So connected image layers that contribute your application image, right? So you'll have a user LAN or the user space, the base file system to start with. Any application that you take, at least it will have 3 different kinds of Dockerfiles that you have to create in order to produce that runnable form of your application, right? So one is the base file system file, wherein you package all your user space related stuff, and then one Dockerfile which comprises of all the language related dependencies, runtimes, and so on and so forth, and one file to create your application specific bits. These 3 files put together becomes your runnable application image. And depending on the complexity of the application, you end up having multiple images as well, right? And the challenge with this approach is, like, since it's a layered file, right? if you find any CD in any of these layers, then that layer needs to be patched again, right? So you have to get the patched version of it, rebuild that image, and then you have to rebuild all the other images that are based on that base layer, right? And the same thing is applicable for your runtime layer, and the same thing is applicable for other intermediate layers as well. And someone has to constantly monitor the provenance and the updates of all these different layers to make sure that it's free of all this critical and high CVEs, right? These things are very, very important. And right, if you're starting small, if you're starting with 5 to 10 containers, then you'll not see the pain. You'll be able to manage it with your own crafted Docker files. But once you scale, once you run containers at scale, hundreds of thousands of containers in production, managing all these things is not really an easy thing, by the way, right? So it's very time consuming, and understanding the source and the proof of all these different layers, and then making sure that we continuously pull in all these patched versions from all this upstream, it's not an easy thing to do. That's where cloud native build packs come in, right? So it simplifies and eases the job of both developers and operations people, right? What does it do? As I told you before, CNB, Cloud Native Buildpacks, is a CNCF incubated project. It's an open standard specification that defines how to produce a runnable artifact right from your application source code. In order to understand CNB, in order to understand this specification, we need to know about 3 important things. Let's try to understand what are those 3 important things. Buildback is software that either fully or partially transforms your application source code into a runnable artifact. For example, if you have an application that's built based on Java, a Buildback is a layer that would contribute the necessary runtimes in order to run your Java-based application. A Buildback does not need to be you can have multiple Buildpacks for each and every language runtime. It does not need to be like a single Buildback would contribute all the necessary dependencies of the language that you deal with, right? So you end up having multiple Buildbacks for one language. In a similar way, you'll have multiple Buildbacks for different languages as well. So the Buildback's role is to take your source code and then contribute something to make sure that you'd be able to transform your source code into a runnable artifact. And the second important thing is the lifecycle. Lifecycle is again a piece of software that orchestrates these Buildpacks together. The role of the lifecycle is to make sure that it brings in all the necessary Buildpacks, and then it transforms that resulting artifact into an OCA conformant image, so that you can take that image and then run it on a platform that understands, or run it on a platform with a container local runtime in it. And the third important thing is the platform. The platform is the one that connects this technology with the end users, right? So it takes this whole CNB implementation to the users, right? Basically to the developers and the operations people. And on a high level, it's been defined around these 3 different things: platform, lifecycle, and Buildback. As I mentioned to you before, Buildback is the one that transforms your source code into a runnable artifact. Lifecycle is the one that orchestrates it, and platform takes it to the end users. And in order to fully understand this, we need to know 2 more things about CNB. As CNB is a specification, right? It doesn't really do anything, right? So it defines the roles and responsibility of these different participating layers. But end of the day, you need to have a reference implementation of it. So Builder is more like a reference implementation of CNB. It's again an OCA conformant image. It packs all these things together. It packs all these different Buildpacks being developed and written for different language runtimes. And the lifecycle is the reference implementation of it. It orchestrates all these Buildpacks based on the language that you deal with. And then the Builder is the one that does the heavy lifting of taking your source code and then convert it into a runnable artifact. And along with that Builder, a stack is the one that forms the base of it, right? So any container image that you take, that will always be a user land space, right? The file system operating system space. So stack basically comprises of 2 things: your base file system space. So one is the build image stack, another one is the run image stack. So build image stack would be kind of bloated, because during build time, you would need to have a lot of libraries and dependencies. that are necessary to produce the compiled version of your source code. But the runtime image can be as thin as possible, as tiny as possible, right? It's just enough layer to run your application image. You don't need to package unnecessary libraries and packages to be part of that run image. That's the difference between build and run image. So build image would be used during the build time to produce that OCA image, and the final OCA image would be based on that run image. And the workflow would be something like that on a high level. So you have the source code, you give that source code to the builder, and from the source code, the builder, the first job that it does is to detect what's the underlying language runtime that's been returned with. And then based on that language runtime, the lifecycle would bring in the necessary build packs, and each of the build pack would contribute some metadata information. And during the build phase, based on that metadata information, all the relevant libraries, runtime dependencies are packaged together, laid together, and then finally produces that OCA conformant image. Okay, so we have seen about that specification, and then we have seen the reference implementation of it as well. So it's time to see it in action, right? So let's get into the demo. Yeah, so we also, in the earlier slide, I've also mentioned about kpack and paketo-buildpacks, other than Cloud Native Buildback. So let's try to understand what are those things, right? If you look at the ecosystem of CNB, right? So as I mentioned to you before, CNB is a specification. You need to have a reference implementation of it. The builder is the one that provides the reference implementation. The builder is the one that provides that reference implementation, right? So paketo-buildpacks is again, Cloud Foundry-backed project. That's an open source, community-backed reference implementation of CNB. In a similar way, Heroku has their own implementation, so as Google as well. And platform is the one, as I told you before, that takes this whole technology, the implementation, reference implementation, to the end users. So pack is a CLI-based tool that leverages builder to produce that OCA image. kpack is again a Kubernetes native, full-blown CNB platform that takes this technology to the end user. In a similar way, the reference implementation of your choice can be leveraged in Spring Boot, Tekton, and the commercial distribution of Tanzu build service from VMware, and so on and so forth. Okay, let's see some of these things in action now. Okay, so what you see here is I have split my terminal window into two panes just to show you how to use Cloud Native Buildpack to produce this OCA conformant image for different language runtimes. On the left is on the left is a language that's built using Node.js, and on the right is a Cloud Native source that's built using Go. Right now, what we are going to do is, as I told you before, Pack is a CLI tool that helps you to take that reference implementation to the end user, right? So Pack is something that you can deploy it in your workstation, and from your workstation, you can make use of this different reference implementations to produce that OCA conformant image from the source code. So let's try to understand what are the builders that are available. When you do Pack inspect builders,
Hello, Srini. Can you show the screen bigger because it's so small here?
yeah, can you see now? Is it better?
Little bit again.
How about now?
Okay, it's better.
Right.
Thank you.
Yeah. Okay, this is totally unexpected. Okay. Just give me a second. Okay. What I'm doing here is I've used Pack suggest builders. So this is going to pull all the trusted reference implementations of CNB, Cloud Native Buildpacks. So give it a couple of seconds. This would bring in all the available reference implementations. As you see here, there are different, this is same as what I've mentioned in the slide, right? So paketo-buildpacks is one such reference implementation of CNB. That's from Cloud Foundry community. And then Heroku as their own implementation, and Google as their own implementation. So for the demo purpose, I've chosen Paketo as the default build pack, so that when I do pack build from the source code, it would pick up the Paketo build packs to produce that OCA conformant image from the source code. And then we can also look into what are the different things that are part of the build pack as well. So we'll do that in a while. Before that, let's kickstart that build process. So what I'm going to do now is I'm going to build both this Node.js based application and the Go based application using pack. So pack build. So what I'm doing here is pack build. Build is a command to build this from this local path, which is where my source code resides. And then pull policy is never. No need to pull these images from Docker because these images are already cached locally. And I've given a tag to this. So this is your image name and image tagging, right? So pack build this from the source code, use this name and the tag. In a similar way, let's go ahead and do this for Go as well. So while this happens, let's try to understand what is happening in the console. If you look at the console here, basically the build pack does two things. So one is like, there are two phases in the build pack. The first phase is the detect phase. Detect phase is where the actual magic happens, right? So from the source code, based on the predefined rules, it identifies what's the underlying language runtime is. So in this case, while doing pack build, we did not mention that this is a Node.js based application. That's been detected automatically by the build pack itself. Once it detects the underlying language is Node.js, and then it has started contributing these layers. So these are the different layers, or these are the different runtimes dependencies that we need. We need those things to be part of your final image in order to run this Node.js based application. That's been, these are all the metadata information that would be added to your build phase as part of the detect phase. And analyze is something that's been provided by the platform since I'm running it using PackCLI. What PackCLI does is it goes and verifies the cache layer, whether have you built this image before. If you have built this image before, then these runtimes are going to be part of your local cache. If that's been the case, then you don't need to pull these layers again. What it does is, if these layers are already available in the cache, it just reuses the metadata information. It doesn't use the data per se. It just uses the metadata information. It uses the cache metadata, cache layers metadata information for the build that it's trying to do now. And it's restoring that metadata information from the local cache. And then the next phase is about building it, right? So this is where the compilation happens, and then it produces your OCA image. And finally, it gets exported so that when you run the same build process again, it reuses it from the cache. So if I run the same build again, this time it will be much faster, because since I've run it once, all these layers are already cached in the local file system, so that it reuses everything from the cache layer itself. See, it's restoring the node engine, npm install, and other things from the cache layer. And then the image is built much faster this time. And the same case for Go-based application as well. So as part of the detect phase, it has identified, okay, this is a Go-based application, because there is a go.mod file is there. So from that, it knows that, okay, this is an application that's written on Go. And these are all the different dependencies and runtime layers that need to be part of the final image. So that's why it adds all those metadata information as part of the detect phase. And build is where everything gets layered, right? So all these connected images are being put together and finally produces that OCA conformant image. So this is the image that's been produced, right? So if you want to run this image, just take this image, and then if you do a Docker run -p 8080 to this, you'll be able to run this image. So this is again OCA conformant. Wherever you want to run this image, you would be able to run this image. So if I do localhost 8080, it's just a sample hello world application. So you'll be able to see the output here. And the same image, this is the image that you can take and run it on a platform like Kubernetes as well. So the reason, because since we have chosen a builder, since we have chosen a paketo buildpack builder, that's the one that's going to be used wherever you use this CNB reference implementation, right? So in this case, pack is the tool that's pulling this builder. And while this build happens, it creates a container locally, and all this detect, analyze, restore, build phase, everything would be executed as part of the container, and that's how the final image gets produced. So when you run the same thing on a full-blown platform like kpack, it also does the same thing. End of the day, it leverages these builders to produce that OCA image. So that's how the CNB, the Cloud Native Buildpack, ensures that whatever the image that you produce, it's a consistent, same reusable image. You just build it once, and then you can run it wherever you have a compatible container runtime in place, right? So this is one way of leveraging Cloud Native Buildpacks to build our application. The other way is Spring Boot is also used as a platform. So Spring Boot provides out-of-the-box support with Cloud Native Buildpacks. It's integrated as part of your build tool itself. So based on whichever the build tool that you use, if you use Maven or Gradle, then you can define the task as part of your build tool, so that while you compile your application, you'd be able to produce or build that final OCA conformant image as well. So what you see here is the next demo is more about how we can use Spring Boot. This is more for the Java side of things. So if you are building applications on JRE, so and if those are using Spring Boot frameworks, then you can produce this CNB compatible OCA image as part of the build phase itself using your build tools like Gradle or Maven. So what I've done is I've defined a simple build task here, boot build image. Don't worry about whatever the arguments that you have present to it. So same as pull policy is if not present. So don't pull it from the Docker app. If the image is already, the builder is already in the local machine, try to use the image in the local machine. And I've given a custom name to this image. This is like this is the registry to use. This is the image name, repo name. This is the image name and the tag. And I'm just passing some ENV related information to the build. So use Java version, JRE version 11. And this is the builder that needs to be used. So here I'm passing a custom purpose-built Paketo tiny Java builder so that the runtime image would be more like a distro list, right? So just enough base to run your application image. So if I run this here, the way to run this is, so this is a Gradle-based thing. So if I do Gradle boot build image, that's the task that I have defined. I'm just calling the task as part of my build phase. So what it does is that Gradle, as usual, it compiles your Java source code, and then it produces that fat jar. And after that, since the boot build image task is being given as part of the build phase, it will go and run that again. So out of the box, Spring Boot is integrated with paketo-buildpacks. And then as part of the build instruction, as part of the task instruction, we have given that use this builder to build this application image. So what it does is that it does the same thing. So in this case, from the source code, again, it has identified, okay, it's a Java-based application. These are the contributing layers. So there are 18 build packs that are applicable for Java-based application. Out of 18, based on the information that you pass, certain build packs would participate, certain build packs won't, right? Based on your ENV-related information and other build-related meta information, these layers would participate in the build phase. So out of 18 build packs, 5 build packs have participated in this one. So BuildSoft library is the one that contributes the JRE runtime, and executable jar is the one that produces your fat jar. And then since it's built based on Spring Boot would contribute its necessary dependencies to build your application. And like how the pack build pack worked, detect, analyze. So it goes and looks for all these cache layers. If these cache layers exist and the SHA information remains the same, it reuses those cache layers as part of this build. So it's restoring all those things because all these things are previously built. That's the reason it has pulled in all those cache layers, the metadata information of these cache layers. And then finally, it's contributing rest of the things. So in this case, since we have passed the ENV parameter to use JRE 11, so it's using JRE 11.0.9, right? So reusing the cache layer. And since I've run this build before, so it has picked up the cache layer metadata information. The same information is used as part of this build. And then Spring Boot is contributing all its relevant dependencies. And finally, the image is being built. For example, if I have to change this one, if I have to change it to a different builder, right? So in this case, Bellsoft has contributed Java JRE runtime version 11.0.9. So what I'm going to do now is I'm going to change this builder to a slightly older version. So instead of 11.0.9, I'm going to change it to a different version of JRE. So if I redo my build again, so it's hitting that boot build image task and it's restoring all these things. But if you look at this phase, since I'm using a different builder, and as part of that builder definition, I've used a different build pack, and the runtime being contributed by the build pack is 11.0.7. So that's how the whole build pack is completely, you'll be able to, it's very much extensible. So as a build pack author, all you have to do is that you have to stick to that /bin detect and bin build phase, and then you'll be able to contribute your own layers as well. So in this case, by using a different build pack layer, I've contributed a different version of JRE runtime, right? And in a similar way, let's say if you don't want to use Bellsoft Liberica, rather if you want to use Oracle runtime, or if you want to use SAP Java Machine runtime, then all you have to do is, as part of your builder definition, you would be able to define all those build packs. So if you want to use a different version of Bellsoft, then you can specify the version here. Or altogether, if you want to change Bellsoft with Oracle runtime, then you can specify the Oracle image here, and then you can create your own builder. And as part of this boot build image task, then you can specify your own builder. And when this OCA image gets built, it's going to get built based on the builder that you have asked the boot build image task to use. And accordingly, all those appropriate build packs would participate based on the information you pass, and that's how the OCA image gets built. So if you really want to look into what is part of this image, right? So to understand what we have done here is we have used Gradle to produce this OCA conformant image. I should be able to run this image in my local machine, but everything happened from our source code, right? So if you really want to look into what are the different layers that are part of this image, the best way to do is Dive is an excellent tool. So you can use Dive to explore what are the different layers being contributed by this cloud native build pack. So if I do Dive of this one, I'll remove some of the unnecessary things. Control A, Control V. Right. So these are the different layers that are part of our image, right? So so this is where the runtime, the user land space comes in. So this is built based on Ubuntu Bionic, just enough distroless Bionic as the base image. And then this is where the CNB comes into picture. So the CNB, the reference implementation, contributes all these layers below, right? So the lifecycle launcher is the one that holds information about how to run your application. And then so the Bellsoft Liberica participated in the build, and this layer has been contributed by Bellsoft. And in a similar way, so this is the JRE layer being contributed by Bellsoft. In a similar way, all those build packs that participated in the build phase would contribute the appropriate layers. And this is where the application-related layers would come in. So what you see here is it's a Java-based application, right? So this layer is where all of your application-specific dependencies are there. All the dependent jars are part of this layer. Unlike a fat jar, in this case, the jar has been sliced into 4 different layers. So the topmost layer is where your all your dependencies would be part of it. And the next layer is where all the Spring Boot loader-related files, compile classes would be part of it. And this layer is empty. If you have defined any snapshot dependencies, then all those snapshot dependencies would be part of this layer. And the final layer is where your application compile bits would get into, right? So this gives you a lot of value add, right? So if it's a fat jar, if you change a single line in your fat jar, and if you rebuild your application again, and if let's say if the size of the fat jar is somewhere around 100 and 150 MB, then you have to move the entire fat jar to your registry, right? So that's a lot of data being exchanged from your local machine or from your build system to the registry. By slicing your application this way, what happens is that the dependency layer is something that you don't change very often. You change these dependencies once in 6 months or once in 3 months, right? If you don't change these dependencies, then while building your image again, so this layer would already be cached, would be part of your registry. You don't need to move this layer to your registry. And so is the case with bootloader. The only layer that changes in your image is just this application layer. And the size of this is only 6 KB, right? So it's nothing. It's very small. So whenever your application related bits changes, all you have to do is you have to rebuild this layer. Only this layer gets pushed to your registry. And rest of the things would be reused from the cache or the previously pushed layer itself. So that's how we leverage Buildback as part of our favorite build tools, right? And the third step is, so what we have seen so far is how we can make use of pack to produce this OCA conformant image from the source code by running pack in our laptops and workstation. And the second demo was focused more on the Java's world of things, how we can use Maven and Gradle as the platform to leverage CNB to produce that OCA conformant image. And the third demo is more on how we can use a full-blown build service that runs natively on Kubernetes and then leverage the same thing to produce this OCA image. Typically, in the expectation from the developers would often be like, once I commit my changes to a version control system, I want the build process to kick in, right? So once the changes get into the version control system, we expect the build service to notify all those, to detect all those events, and then start building, start checking out the changes, and then produce that OCA image from the change, right? So kpack is more of a full-blown platform that runs natively on Kubernetes, any OCA, any CNCF conformant Kubernetes. So in this case, I'm already running kpack on a Kubernetes cluster of 5 nodes. So what I'm going to do now is I've already run this build before. So let's do kpack list builds. So kpack from this namespace list the builds that are available, right? So this is going to list the builds that are available. So since I have run this before twice, it's listing that you have run this before and both the runs are successful. Let's say that I want to simulate one more build. So the usual flow would be like you make changes to your application source code in your local machine. And once you're done with your changes, you commit your changes to a version control system. So what I'm going to do is, let's pretend that we have done some changes to our application. I'm just going to do a dummy empty commit to the version control system. So git commit empty, and then trigger build Bogor event, right? So I'm just issuing an empty commit, and then let's push our changes to the GitHub repo. Prompting me for the password. Okay, the change has been committed to our GitHub repo. So if I go back to GitHub, Spring Boot Kubernetes. So this is the commit message that we have pushed to, right? Trigger build Bogor event, right? So if I run the kp command again, so in few seconds now, it would detect the change, and then give it a couple of seconds. While that happens, let's look at the available images. So these are the images that I have created before. So the cloud native is the one that I've created before. So it's listing that build. Okay, it has started, it has picked up our changes. So we made some changes in our local, we pretended as if we made some changes to our local machine, and then we committed that change to the GitHub repo, right? And that's being picked up automatically by the kpack platform that's running on Kubernetes. And then it has started it has started the build process now. So if I do kp- from this namespace, do a build logs of this cloud native, you would get to see the same flow there, right? So what it is doing is you would get to see one additional flow here, because with Pack and Spring Boot, we were doing everything in our local machine because the code was in our local machine. And then we were giving that instruction to Pack and Spring Boot that use the code that's residing in so-and-so path. Whereas in the case of kpack, it's coming from a centralized version control system. So it has to clone that source code from that version control system to the local container. So that's the prepare phase. Prepare phase is more about hit that version control system and then download the source code to the local container. And then the same process what we have seen with Pack and Spring Boot based platform. So as part of the detect phase, it has identified, okay, this is an application that's built on Java. So it has got 32 appropriate build packs, out of which 6 build packs are participating in this build phase. And since I have built this image before, it's restoring that metadata information again from the cache layer. And then it's the build software is contributing JRE related stuff, and then executable jar, Spring Boot related stuff. And finally, it's building everything from the source code. The Gradle daemon kicks in, and then it compiles the source code and produces the jar. And the jar would get sliced up again, as we have seen by our dive. It gets sliced up into 4 different layers, like dependencies, Spring Boot loaded layer, snapshot dependencies, and the application bits. And finally, the OCI image gets built, and it gets pushed. It gets pushed to the repository as well. So finally, if you go to your repository, so this is the output, right? So when you create a KP image, that the instruction would be like this. So image create would be like KP in this namespace, create an image with this name, and it needs to be tagged this way. So this has to be the output of this build process. So what I expect out of this build process is more about once the image gets built, it needs to be pushed to this registry under so-and-so repo. And the input to this is the GitHub repo, and use this revision to extract, to clone the source image from the version control system. So if we go back to this repository, registry, so this is again a registry powered by Harbor. Our image name is sys.humormind.com, KNA is the repo name, and Spring Cloud Kubernetes version 2. If I go to KNA repo, and if I get into Spring Cloud Kubernetes, and you get to see the version 2 image that just got pushed to this registry, right? So that's how a full-blown KP kind of a platform on a Kubernetes-based runtime would work with Cloud Native Buildpacks. So again, with KP, you can find out all these different builders as well. So when you do cluster builder list, it would list all the builders that are available in this platform. So in this case, it has got 4 different builders: base, default, full, and tiny builders. And then you can look into these builders as well. And I told you before, so if you, for example, if you take this built image, if I take this built image, if I inspect this image, this command from Pack would give you the information about this image, how this image is being built, what are the participating Buildback layers, and what are the different processes that are part of this, how it's going to get executed, and all those things would be part of this image. If you need more information about what are the different dependencies and layers that are part of this image, so you can get the complete bill of materials as well. So give it a couple of seconds. This would give you a nicely formatted JSON with all the layers with SHA information that are part of this image. So if I go all the way up to this image, here you can see some metadata information is there. They have pulled in the license information as well. So this is the JRE license information. So if you have any compliance or regulatory requirements where you have to produce this information, you'll be able to produce this information as well. So this is the Buildsoft Liberica JRE layer that's been part of this image. This is the SHA reference. In case if this gets changed, if you use a different builder, the SHA reference, it's going to be different. So that's when you do a build, it wouldn't be able to restore it from the cache. So that needs to be contributed fresh again. And this is where the JRE it's been downloaded from. And in a similar way, you get to see other layers as well. And if you go further down, you'll get to see all your application-specific dependencies as well. So all your Jackson-related dependencies, Spring Boot-related dependencies, all those things would be part of the bill of material information, right? So if you go further down, you get to see everything. The different layer, different dependencies that are part of it, the SHA information and all those things. So that's how it does the comparison when you redo the build of the same image again, if it's already been built. If the SHA information remains intact, if it's not changed, then it reuses all this metadata information from the previously built layer. That's about the bill of materials that you get to see with pack inspect, right? And moving on, so these are the three things that I wanted to show from a demo perspective. So we saw how we can use pack to build this image, and then Spring Boot, and finally a full-blown platform like kpack to produce this OCA conformant images. Going back to the presentation again, one final slide. So this is how typically a build service would look like, enterprise commercial distribution of build service would look like. So the build service is at the center of this whole ecosystem, and then it points to your source code repo, and then you'll have a private registry. That's where you keep all your Buildback OCA images plus the stack related images. And build service is going to continuously watch these two sources for any updates. Whenever a source code gets updated, or whenever any of your meta pack related info or the stack related information gets updated, it picks up all those changes, and then it automatically rebases, rebuilds your images, right? So that's how the OCA conformant image gets produced. Another important thing is, I'm not sure whether I have the time to show you that part as well. So the rebasing part is very simple with build service. So in a Docker file-based build mechanism, whenever you have to patch your base OS file system, you have to pull that updated patched image, and then you have to rebuild all your application images that were built based on that base image, right? Whereas with Cloud Native Buildpacks, you don't need to rebuild your application layer again. All you have to do is it follows the same principle of the Buildback technology that's being used in the cloud in Cloud Foundry platform. So that there is a clear demarcation between what are the layers being contributed by your application and the layer, the file system layer that's been coming from the infrastructure layer itself. So whenever you need to patch your base OS file system, what it does is that once you have that updated stack base, your runtime stack base, basically it has to go and update that metadata information of that stack base in your application image. So through this application binary interface contract, it ensures that changing the stack image will not break any of the contracts that's being established between your application layer and the underlying stack layer and underlying infrastructure layer. So rebasing or rebuilding, the patching your base layer OS is not a big deal with build service, and it happens in a matter of few seconds. In the world of Dockerfile, if you have hundreds of thousands of containers, rebuilding it would take a longer time. Whereas with Cloud Native Buildpacks, it's just about updating some metadata information, and the size of that update would be in few kilobytes. That is that information that needs to be pushed back to your registry. So once you redeploy your application again, it would, based on that OCA image specification, based on the defined metadata information, updated metadata information, your image your image gets patched with that updated stack image. That's how the base OS file system related rebasing happens with Cloud Native Buildpacks. That's it. Thank you very much. Once again, thank you very much for the opportunity. I hope to see you guys soon.
Okay, thank you, Srini, for the insightful presentation. Next, we have several questions. First, from Mas Giri Kunchoro. How would this open source version of Buildpacks be different from the one currently running on Heroku platform?
Yeah, so Heroku okay, let me share my screen again. Okay. I ran this command before as well, right? So when you do pack suggest builders, this is going to pull you all the different open source implementation of CND Buildback. And Heroku Buildback is again a reference implementation. The open source version is available. And you would get to see the same thing on Heroku platform as well. So they probably would have added some enterprise flavor to it, similar to what we have done with kpack. So kpack is again a reference implementation that's based on paketo-buildpacks. So paketo-buildpacks is again an open source reference implementation. With kpack, we have added some of the flavors like listening to your source code repository, and then whenever the builder or any of the stack layer gets updated, it goes and pulls all those updates automatically. Whereas with paketo-buildpacks, it's just the builder implementation, right? So what it does is, given a source code, it's going to produce that code-free conformant. Even with Heroku platform or a commercial distribution of paketo-buildpacks, the builder would remain the same. You get to see the same thing there, but they would have added some enterprise flavors on top of it. That's the difference.
Okay. The next question from Mas Prakas. Is there any specific configuration to decrease the container size of build image like multi-stage Docker?
Yeah. So as you see here, the paketo-buildpacks has got 3 different implementations. One is base, full, and tiny. If you look at the tiny implementation, the runtime image is more like a distro list. So it is just enough container base to run your application image. So it does not include any of the unnecessary libraries and dependencies. And that's how it ensures that the runtime layer is as tiny as possible. And then other than that, you have different layers that would participate in the build phase, right? So based on whatever you have included as part of your build time instructions, these layers are going to come. These layers are going to participate, and they are going to produce that appropriate layers to be part of the final. So again, it depends on the languages that you deal with and the kind of dependencies that you need. So if it's just a simple cloud native application, not bundled with a lot of third-party dependencies and all, it's just a tiny runtime layer as well as the contributing layers. But if you have included a lot of third-party dependencies like a monitoring agent, logging agent kind of things, then these agents are going to contribute its own layer as well. So that's going to add that overall size. Similar to multi-stage Buildback, we do the same thing with multi-stage Buildback as well. So the build in a multi-stage Buildback, as part of during the build phase, we include a bloated base image with a lot of libraries that typically we would need in order to build that image. Whereas the runtime image, the final image that we produce in a multi-stage build, the runtime image will be as tiny as possible. So Cloud Native Buildback does the same thing. So based on the builders, you'll be able to produce an image with just enough layers to run your applications.
Okay, so for the decreased container size, it's same with multi-stage Docker. Okay, another question from Mas Egi Mesandi. Can Buildback speed up the build time of Docker image like Docker build kit. So the question about
answer is yes. That's what we have seen that's what we have seen with Spring Boot and Pack, right? So once you run the first time, it will be like it takes some time. When you run the build for the first time, it has to download all the dependencies. So that's when it takes longer. Once the build happens, the metadata information and the actual data itself gets cached locally. So when you rerun the build again without changing anything, everything is going to be reused from the cache layer. Let's say that if you have changed one layer, application layer, so all but application layer would be reused from a cache layer. So since you have cached your application layer, the star information will be different. So that layer needs to be built again. So that's how it improves that build up. So first time takes longer time, but the subsequent builds would happen in a fraction of seconds, in few seconds.
Okay, thank you. Another question from Mas Iqbal. Are we have to define project the TOM before running CNB on our project?
Not really. So the best way to get started is to go with pack CLI, or if you're building a Java-based application, then you can quickly get started with Spring Boot. So project.tom TOML is something that you can define as well, but in order to get started with CNB, that's not a mandatory thing. All you need is the pack CLI, deploy to your local machine, and then get started with pack CLI.
Okay. The last question from Mas Giri Kunchoro. In my workplace, we SRE team have abstract Docker files and provide sets of golden image depending on language. So devs just need to use, no need to write. How would Buildback help us with this?
Yeah, it's the same thing. Probably I'll show you a sample builder image. I don't think I have the time to run this builder image. So if you look at this builder image, so I have used a meta builder, meta buildpacks. So I'm just pulling it from meta buildpack named paketo-buildpacks in Java, right? So, but if you look into that meta buildpack, so these are the different layers that will be part of. Similar to how we have abstracted based on different Docker files. Right? So you have abstracted in such a way that, so this is the Docker image for, let's say, Ubuntu Trust. This is the Docker image for Ubuntu Bayam. And this is the Docker image for Java 8. This is the Docker image for Java 11. So that's what we define as part of this build pack. So each build pack becomes your contributing golden image layer, right? So in this case, the build shop, like Eureka, is going to contribute a specific runtime of Java. So in a similar way, you can have multiple builders, right? So one builder with Java 8, one builder with Java 11, one builder with Java 14. And in a similar way, you can maintain multiple builders. So that becomes your golden copy. So developers don't need to worry about any of this. It's a one-time setup. As ops or SREs, you would do it only once, depending on what the core policy is all about. If you decide to support multiple different runtimes for a language, then you'll have two different builders to support it, right? So this is pretty much extensible. You can take one of the available Paketo open source buildbacks, and then you can contribute your own buildback layers as well. So you'll be able to override the default as well. When you do pack build, during that time, you can specify your own golden images as well. So that's how CNB works. It's the same thing. Whatever we used to do with Docker files, the same thing is being done by CNB in a much better way. So as developers or SREs, we don't need to deal with Docker files anymore. Right? So Docker files are great, it's flexible, but you have to learn the nuances of the Docker file if you really want to produce a secure, hardened, production-grade container file. Right? So that's been simplified with the help of cloud native.
Okay, Srini, thank you for giving us the insightful presentation and answering some question. The next talk will be in Bahasa. You can stay here or have a conversation in our commentar. Once again, thank you.
Thank you. Thank
See
you
you
all.
and
Thank you all.
next meetup.
Thank you for the opportunity. Hope to see you guys. Thanks.
Oke. Next teman-teman kita punya Mas Ausafi. Langsung aja. Oke, Mas Ausafi boleh
Oke, suara saya kedengeran nggak?
Oke, jelas Mas.
Oke, baik. Terima kasih Mbak Sartika untuk atas waktunya juga. Dan terima kasih buat teman-teman yang udah hadir untuk acara meetup kali ini. Dan pada kesempatan kali ini mungkin saya akan perkenalkan diri saya terlebih dahulu. Oke. Oke, can you see my screen? Oke, sebelumnya mungkin perkenalkan dulu ya untuk nama saya Muhammad Ausafi Setiawan. Saya bekerja di PT Infrakom Teknologi sebagai Solution Engineer, dan pada kesempatan kali ini saya akan membawakan untuk salah satu tools yang dimana kita dapat melakukan suatu remote container operation dengan menggunakan yaitu Skopeo seperti itu. Nah, mungkin sebelum kita lanjut bahas untuk paketo-Skopeo, kita akan mendefinisikan dulu permasalahan apa sih yang sebenarnya terjadi ketika mungkin teman-teman ya yang sudah terbiasa dengan operasional terhadap suatu container image atau image yang ada berada di dalam container registry dan container image yang juga ada di hostnya teman-teman seperti itu. Nah, mungkin misalkan kita melakukan suatu operation terhadap container image kita, misalkan kita akan melakukan suatu Docker inspect seperti itu. Nah, secara tradisional kita akan melakukan yang namanya Docker pull terlebih dahulu. Kemudian kita akan melakukan download image ke localhost kita, dan kemudian kita baru bisa menjalankan Docker inspect tersebut seperti itu. Nah, permasalahan ini menjadi cukup sangat kritikal ya teman-teman, karena pada dasarnya untuk melakukan suatu operation, misalkan saja Docker inspect seperti itu. Nah, kita selalu melakukan yang namanya Docker pull terlebih dahulu. Dan itu akan cukup memakan resource yang ada di local host kita seperti itu. Nah, dengan menggunakan Skopeo ini kurang lebihnya kita dipermudah dengan kita dapat melakukan beberapa operation yang dimana kita tanpa perlu melakukan Docker pull terlebih dahulu, kita dapat melakukan operation tersebut. Misalkan seperti command Docker inspect, kita dapat melakukan secara stream dari remote container repository seperti itu, atau container registry. Jadi ini adalah salah satu tools initialized by Red Hat untuk pertama kalinya, dan kemudian Skopeo ini juga di-initialize untuk ke open source seperti itu. Kemudian kurang lebihnya untuk Skopeo sendiri, dia tidak memerlukan untuk daemonless bisa dibilang untuk melakukan suatu operationnya. Kemudian juga Skopeo ini tidak memerlukan access root untuk menjalankan command line tersebut. Kemudian untuk Skopeo sendiri, dia dapat melakukan dia juga bekerja terhadap OCI image format dan juga untuk Docker versi 2 image format seperti itu. Kemudian juga Skopeo ini bekerja untuk menggunakan API version 2 container image registry dan juga bisa untuk private registry, local directory, dan yang lain-lainnya seperti itu. Itu kurang lebihnya untuk Skopeo. Kemudian untuk skenario use case yang kita coba bawakan, kurang lebihnya dari Skopeo sendiri untuk kapabilitasnya, kurang lebih kita bisa melakukan suatu copy operation yang mana kita bisa memindahkan image container kita dari satu repository ke repository lainnya seperti itu, tanpa harus melakukan Docker pull atau Docker pull kemudian Docker tag, dan kemudian kita melakukan Docker push ke container registry tujuan seperti itu. Nah, kita dapat melakukannya secara stream dari satu kontainer ke kontainer lainnya dengan cukup mudah seperti itu. Kemudian kita juga dapat melakukan inspect seperti yang tadi saya bilang, bahwa kita bisa melihat untuk konfigurasi dari container image property kita seperti itu tanpa harus melakukan Docker pull terlebih dahulu. Dan formatnya juga bisa kita formatnya JSON ya, JSON. Kemudian kita bisa melakukan operation selanjutnya yaitu delete container image dari image registry secara langsung seperti itu. Kita tanpa harus melakukan membuka web GUI dari image registry, kita bisa melakukan operation delete container image kita seperti itu. Kemudian untuk kapabilitas dari Skopeo sendiri yang terakhir kurang lebihnya adalah synchronize. Jadi kita dapat melakukan suatu synchronize image dari satu repository ke repository lainnya seperti itu. Nah, Skopeo sendiri juga sebenarnya bisa sih diintegrasikan dengan CI/CD seperti itu. Dan ini sangat menurut saya sendiri, menurut saya pribadi ini sangat membantu seperti itu. Karena pada dasarnya untuk operasional yang sederhana seperti ini ternyata cukup penting kayak gitu. Oke, next. Ini adalah salah satu contoh untuk komen, yaitu yang pertama kita lakukan adalah seperti pada umumnya. Jadi ketika kita ingin bekerja dengan suatu container image repository, kita akan melakukan authorization terlebih dahulu, yaitu kita menggunakan command Skopeo login seperti itu. Kemudian diikuti dengan registrinya. Kemudian kita bisa melakukan operation selanjutnya, seperti misalkan kita ingin melihat suatu konfigurasi dari container image kita yang ada di repository, kita bisa langsung untuk scan dengan format API versi 2 ya, jadi ada docker /2 kemudian // registry, nama registrinya, kemudian repositorinya, dan kemudian diikuti dengan image, kemudian lalu text seperti itu. Kemudian ada parameter min config untuk melihat config keseluruhannya. Kemudian kita bisa melakukan suatu operation lain, misalkan dalam hal ini kita akan melakukan copy image kita dari satu container registry ke container registry yang lainnya seperti itu. Kemudian ada lagi operation yang kita bisa lakukan, misalkan kita ingin migrasi container image registry kita dari satu container image repository ke container image repository yang lainnya seperti itu kurang lebihnya. Oke, next-nya mungkin kita ada demo time sebentar aja untuk demonya. Kurang lebihnya kita akan melakukan migrasi, yaitu untuk container image kita. Di sini sebagai contoh saya akan memindahkan container image kita yang ada di Docker Hub. Kemudian kita akan pindahkan ke private repo. Misalkan kita akan pindahkan ke quay.io seperti itu. Nah, oke, kita coba untuk demonya. Oke, yang pertama-tama kita bisa coba untuk login terlebih dahulu. Jadi yang di sini yang kita perlu lakukan adalah command Skopeo login, and then diikuti dengan registrinya. Kemudian kita masukin username dan juga kita masukin password dari repository kita seperti itu. Selain itu, untuk loginnya sendiri, teman-teman bisa pakai beberapa metode. Yang pertama adalah token, yang kedua ada
Mas, boleh minta tolong diperbesar ya?
Oke, sebentar.
Makasih.
Oke, sama-sama. Oke, mungkin udah kelihatan ya teman. Nah, di sini kita bisa coba beberapa metode sebenarnya dalam command login. Jadi kita bisa kurang lebihnya untuk metode yang diberikan dari si Skopeo ini kurang lebih sama seperti yang ada komen pada Docker atau OCI yang lainnya. Nah, ini kita bisa coba untuk menggunakan file, autentikasi file. Ini formatnya adalah token ya, based on token. Kemudian ada based on certificate. Kemudian juga bisa pakai username password seperti itu. Nah, kemudian setelah kita berhasil login ke container image repository, kita bisa melakukan operation selanjutnya itu. Nah, di sini kita coba ngelakuin beberapa operation. Salah satunya kita bisa coba untuk ngelakuin inspect, misalkan kita coba tes. Nah, untuk format registrinya kita bisa menggunakan yang Docker ya, Docker //, kemudian diikuti dengan registrinya, misalkan di sini kita coba untuk yang inspect untuk container image yang atas. Nah, untuk outputnya dia tidak berurutan seperti ini, dan kita bisa menggunakan tambahan opsi dengan pipe. yaitu JQ. Dan kita akan ngeparsing outputnya menjadi JSON seperti itu. Nah, kita bisa melihat banyak konfigurasi teman-temannya dari sini. Ini banyak banget. Mulai dari arsitekturnya, kemudian ada operating system yang digunakan, kemudian ada environment variable, entry point, CMD, dan lain-lainnya seperti itu. Kemudian kita juga bisa lihat untuk layernya, layer yang dipakai. Dan kemudian ada juga untuk setiap layernya nih, detailnya seperti itu. Nah, kemudian kita bisa melakukan operation lainnya selain kita melihat konfigurasi dari container image-nya, kita bisa melakukan cek untuk list tag apa aja sih yang ada di dalam container image kita seperti itu. Nah, komennya kurang lebih, Skopeo list tags, kita akan melihat operation untuk melihat beberapa tag yang ada di dalam container image kita. Nah, di sini kita bisa melihat untuk informasi dari repositorinya, kemudian kita bisa lihat untuk teks apa aja yang ada. Nah, di sini kita memiliki 3 teks atau 3 tag untuk image kita seperti itu, informasi image-nya. Nah, kemudian kita juga bisa melakukan copy, misalkan operation copy. Nah, untuk operation copy ini, di sini saya kan menggunakan untuk tujuan dari image repository-nya, yaitu kita menggunakan paketo-buildpacks. Dan di sini saya sudah membuat satu repository dan tidak ada teks yang ada di sini. Seperti itu. Nah, kita coba untuk memindahkan, misalkan, Skopeo, copy, and then diikuti dari source-nya, jadi diikuti dari source-nya. Di sini ada parameter yang pertama itu source image-nya, kemudian diikuti dengan tag-nya. Misalkan di sini saya akan copy untuk yang versi latest, kemudian diikuti dengan destination dari container image registry tujuannya seperti itu. Misalkan play.io, and then diikuti dengan autentikasi file untuk destinasi tujuannya seperti itu. Karena kita di sini membutuhkan 2 kali ya, atau bisa dibilang source-nya kita membutuhkan autentikasi, kemudian untuk destination-nya di sini kita juga membutuhkan autentikasi file credential seperti itu atau token-nya. Nah, teman-teman bisa lihat di sini kita akan coba copy, dan di sini ada informasi untuk setiap layarnya yang akan di-copy. Dan untuk Skopeo sendiri ini tidak membutuhkan Docker ya teman-teman ya, atau yang lainnya. Dia standalone CLI, bisa bekerja seperti itu. Jadi kita nggak perlu dependensi untuk ke Docker atau yang lainnya. Nah, ini teman-teman bisa lihat di sini udah ada informasi untuk setiap layarnya yang di-copy. Kemudian kita juga si Skopeo ini nyimpen untuk e-signature-nya seperti itu. Dan kita bisa lihat untuk di repository tujuannya, kita bisa lihat bahwasannya kita udah berhasil untuk copy image-nya seperti itu. Ini ada informasinya, last modified-nya few second ago, and total size-nya ada kurang lebih 346 MB. Dan teman-teman bisa bayangkan kalau ketika teman-teman melakukan copy tanpa menggunakan Skopeo, teman-teman akan lakuin yang namanya Docker pull terlebih dahulu ke host-nya. Jadi kita bakal ngelakuin Docker pull seperti ini, and then kita akan lakuin Docker tag, source-nya, and then destination-nya. Seperti itu. Kemudian kita baru ngelakuin docker push ke repository tujuannya. Seperti itu. Nah, dengan menggunakan Skopeo ini kita lebih mudah sih, bisa dibilang lebih mudah, tanpa harus ngelakuin beberapa step di atas. Seperti itu. Kita ngelakuinnya secara stream gitu. Dan ini bisa menghemat resource dari disk yang ada di host kita. Jadi nggak perlu untuk storing container image seperti itu. Nah, kemudian case yang terakhir adalah kita coba migrasi. Coba migrasi. Nah, misalkan di sini saya ada satu repository, satu image, dan beberapa tag. Kemudian kita akan pindahkan ketiga image tag ini ke repository tujuan. Di sini misalkan, di kwe.io seperti itu. Nah, kita bisa ngelakuin dengan menggunakan operation synchronize. Seperti ini. Oke, so kurang lebihnya untuk operation synchronize yang dibutuhkan adalah source-nya. Source-nya ini dia bisa dari YAML file ataupun dari lokal image. Maksudnya lokal directory. Kemudian destination-nya ini bisa berupa registry, formatnya Docker seperti ini, atau juga bisa destination-nya ini berupa directory seperti itu. Jadi misalkan kita nyimpannya di lokal nih, itu bisa. Kemudian diikuti dengan source dari image-nya, kemudian diikuti juga dengan registry tujuannya, dan juga untuk destination-nya kita juga memerlukan authentication file seperti itu, yang sebelumnya kita udah buat. Nah, ini kita bisa coba lakuin. Oke, so ini ada error sebentar. Untuk errornya sendiri, oke, wait, I will check it. Sebentar. Okay. Oke, ini ada error, teman-teman. Kemungkinan karena kredensialnya. Ini coba saya Skopeo login dulu. Sorry. Oke, kita coba lagi untuk testing untuk migrasinya. Oke, errornya masih sama. Mungkin kita akan coba untuk operation yang lainnya. Misalkan kita bisa ngelakuin delete operation, kemudian kita juga bisa ngelakuin beberapa operation. Ini kurang lebihnya kita ada beberapa kapabilitas untuk si Skopeo ini, yaitu copy, delete, spec. Kemudian kita juga bisa verify untuk signature dari container image kita. Kemudian terakhir synchronize. Oke, mungkin saya akan sudahi untuk share screen-nya. Maybe nanti kita akan coba lagi untuk synchronize operation, dan mungkin jika ada teman-teman ada pertanyaan boleh disampaikan seperti itu. Oke, ada pertanyaan teman-teman? Mungkin dari saya cukup sekian.
Oke teman-teman, mungkin ada yang mau bertanya tentang materi yang sudah disampaikan oleh Mas Ausafi tadi. Ini tadi ada pertanyaan dari Mas Aditya, kalau private registry gimana Mas?
Oke, selagi private registry-nya itu atau container registry-nya ini mendukung Docker API Flash itu, ini bisa seperti itu. If seperti mungkin perbandingannya kayak misalkan container registry hardware gitu ya, kemudian ECR dan yang lain-lainnya itu bisa sih. Seperti itu.
Kita masih punya waktu, mumpung masih ada Mas Alsafinya di sini, teman-teman yang mau bertanya bisa bertanya langsung supaya bisa langsung dijawab. Silakan langsung ketik di kolom chat. Mungkin pertanyaan dari saya kali ya Mas. Jadi sebelumnya ada beberapa artikel yang saya baca kalau Skopeo ini dia bisa jadi tools alternatif pengganti Docker. Menurut Mas Ausafi sendiri ini apa sih kelebihannya? Kenapa dia bisa disarankan menjadi tools alternatif pengganti Docker yang sekarang tuh banyak banget dipakai?
Oke, mungkin kalau dibilang untuk menggantikan Docker sih bukan sih, karena sebenarnya kalau bisa dibilang menggantikan Docker, karena pada dasarnya tools ini atau Skopeo ini dia bandel sih sama, mungkin karena dari bawaan Red Hat gitu ya, kemudian bandelnya sama Podman, perbandingannya seperti itu. Dan kalau bisa dibilang mengganti, kalau misalkan kita bicara tentang Skopeo-nya saja, itu enggak sih, enggak bisa, enggak menggantikan Docker.
Oh. Oke, berarti harusnya bukan menggantikan ya, cuma mungkin melengkapi lebih tepat atau?
Yap, melengkapi untuk container tool seperti itu.
Oke, ini ada pertanyaan dari Mas Giri. Kegunaan utamanya selain buat nge-sync multiple container registry, apalagi ya ini buat use case-nya gitu?
Oke, kalau dari use case yang saya alami deh, saya coba juga. Itu kurang lebihnya sih dibuat integration juga untuk CI/CD juga sih Mas. Gitu. Jadi kita pakai ini pada dasarnya itu buat nge-synchronize pada flow CI/CD pipeline seperti itu. Dan seperti yang tadi saya bilang, untuk kapabilitas dari si Skopeo sendiri ini kurang lebihnya ya baru seputar tentang copy, delete, kemudian ada melihat teksnya, list tag, kemudian juga bisa ngelakuin synchronize seperti itu. Kalau use case utama mungkin lebih ke arah kebutuhan ya. Kalau kebutuhannya misalkan buat copy dan delete, mungkin itu bisa jadi kegunaannya seperti itu. Dan yang paling penting sih untuk menghemat resource ini ya, karena pada dasarnya menggunakan Skopeo ini nggak perlu ngelakuin Docker pull seperti itu, dan kemudian Docker push atau mengunduh kontainer image-nya terlebih dahulu, kemudian kita baru ngelakuin operation-nya seperti itu. Kita cukup ngelakuinnya secara stream dari remote image registry. Seperti itu.
Oke, pertanyaannya dijawab sama Mas Alsafi. Teman-teman ada lagi mungkin pertanyaan atau Mas Alsafi ada tambahan dari materi ini?
Mungkin apa ya, untuk Skopeo sendiri nih karena versionnya baru rilis 1.2 kalau nggak salah itu latestnya, dan kemungkinan juga masih jalan sih untuk roadmap untuk fitur selanjutnya.
Mas, ada pertanyaan lagi nih dari Mas Muhammad Ridwan. Saat menggunakan Skopeo, apakah ada batasan data saat sync antar registry?
Oke, kalau dari batasan data, biasanya kalau dari Skopeo sendiri ini nggak ada ya, karena dia sekedar provide. Kemudian biasanya kalau batasan data ini adanya pada limitasi dari container image registry. Seperti mungkin teman-teman juga udah tahu ya, kalau misalkan Docker Hub ini yang basic account, dia akan dapat limit, kurang lebihnya seperti itu. Jadi kalau kita misalkan dapat limit, katakanlah kita dibatasin untuk 10 image, misalkan pool ya, 10 image pool operation dalam sehari gitu misalkan. Nah kemudian kita kalau misalkan lebih dari itu otomatis nggak bisa. Itu limitasi pada container image registry-nya, bukan pada Skopeo-nya seperti itu.
Oke. Kita tunggu teman-teman, mungkin masih ada yang lagi mikirin pertanyaannya, mungkin kita tungguin sekitar 5 menit lagi ya Mas.
Oke.
Teman-teman yang mau bertanya, jangan ragu-ragu ya. Kita di sini sharing, diskusi, bakal dijawab sama Mas Alsafi. Jadi kalau mau ditanya langsung diketik aja di kolom chat, jangan ragu. Oke, ada pertanyaan lagi dari Mas Muhammad Ridwan lagi. Saat menggunakan Skopeo untuk sync antara registry, itu sebenarnya menggunakan kongsi pengguna atau kongsi antara registry? Maksudnya untuk kirim antara registrinya.
Oh itu untuk koneksi ya mungkin ya biasanya.
Iya, koneksi.
Iya, antar registry sih Mas. Bukan dari host ke registry. Dia langsung dari registry. Registry to registry biasanya.
Oke, teman-teman, ada lagi kah yang mau ditanyakan? Atau Mas Ausafi ada lagi mungkin tambahan tentang Skopeo-nya? Info-info atau mungkin Mas Ausafi sumbernya buat ngulik atau ngoprek si Skopeo-nya ini dari mana? Bisa diinfoin ke teman-teman mungkin?
Oke, kalau untuk sumbernya ini dari ini sih dari GitHub-nya Skopeo officially. Dan di situ dokumentasinya lengkap teman-teman. Kalau misalkan mau coba pack lebih dalam lagi.
Ini ada pertanyaan dari Kaspin. Skopeo ini udah banyak digunakan di production apa belum ya, Mas?
Dalam kelas saya sih masih dalam testing gitu ya di dev buat tambahan CI/CD pipeline aja sih seperti itu, Mas.
Oke, ada pertanyaan lagi dari Mas Ridwan lagi. Pengalaman saat digunakan, apakah ada batasan bandwidth-nya, Mas?
Nggak ada sih kalau batasan bandwidth. Tidak ada batasan. Mungkin batasannya lebih cenderung kalau misalkan kita menggunakan private repo ya, dan itu kan ada, kalau private repo kan kita deploy-nya pasti di environment kita gitu ya, itu berarti bergantung pada kecepatan bandwidth internet kita sih seperti itu.
Ini lanjutannya, saat sync antar registry tuh ada batasan bandwidth-nya gak, Mas?
Enggak sih, Mas, enggak. Dan juga saya juga belum dapat untuk view ke sana, point of view untuk melihat visibility bandwidth-nya, pengirimannya. Kebetulan di Skopeo ini nggak ada. Jadi bisa dibilang sih itu mungkin tergantung dari content remes registry-nya sih.
Oke. Nah, ini ada lagi dari Mas Aditya. Nah, itu Mas, kalau private repo ada pricing-nya, Mas?
Untuk Skopeo sendiri ini open source ya, jadi untuk pricing-nya nggak ada sih. Mungkin lebih pricing kalau misalkan kita pakai private repo dan private repo tersebut harus menggunakan license seperti itu. Jadi untuk Skopeo-nya sendiri ini tools-nya open source ya, dan free.
Oke. Dari Mas Safi ada tambahan lagi kah? Atau cukup? Atau ada tambahan lagi?
Oke, mungkin kalau dari Skopeo sendiri ini kan karena dia baru rilis ya, rilisnya sih saat ini masih versi 1.2 dan mungkin teman-teman ada yang berminat untuk kontribut ke Skopeo project ini mungkin bisa cek di GitHub aja ya untuk how to-nya. Karena ini masih baru banget sih seperti itu dan roadmap-nya mungkin lebih banyak ke depannya seperti itu. Jadi untuk kapabilitasnya dan yang menggunakannya pun itu masih belum banyak seperti itu.
Ini ada pertanyaan dari Mas Ervin. Bisa buat yang berbasiskan CRY?
Bisa Mas, jawabannya bisa.
Oke. Mas Ausafi udah nggak ada tambahan lagi ya? Atau masih ada?
Udah nggak ada sih.
Oke, kalau gitu mungkin bisa kita udahin aja ya, Mas Ausafi. Terima kasih banyak atas presentasinya, materi Skopeo yang baru ini dan mungkin belum banyak artikel-artikelnya dan masih abu-abu. Nanti teman-teman yang mau info-info tentang Skopeo bisa kontak Mas Ausafi langsung karena Mas Ausafinya ada di grup komunitas Cloud Native untuk nanya sumber-sumbernya. Sekali lagi terima kasih Mas Ausafi. Sampai bertemu di meetup selanjutnya.
Baik, terima kasih Mbak Sartika. Sampai ketemu di meetup selanjutnya.
Oke. Oke, teman-teman, kita lanjut ke yang tadi udah ada 2 pembicara keren yang ngebahas tentang Cloud Native Buildpacks, salah satu project CNCF yang masih dalam inkubasi kalau nggak salah terakhir saya lihat. Terus tentang Skopeo, tools baru untuk containerization. Selanjutnya kita bakal lanjut ke announcement. Announcement-nya ini ada teman-teman yang punya meetup topik, ide-ide untuk topik-topik selanjutnya atau request, atau ada dari perusahaan ada yang mau dijadiin topik materi meetup selanjutnya, bisa submit ke repositorinya Cloud Native ID di ISUS. Next-nya untuk Kubernetes IO ID untuk translation ada 260 halaman yang udah ditranslasi dan ada 84 kontributor di hitungannya dan kebanyakan dari mereka adalah first time kontributor. Ada 186 pull request dan terakhir update-nya ada 8.000 views per bulan di translation ID di kubernetes.io. Selanjutnya ada 2000 ISUS tracking-nya ini ada teman-teman bisa lihat di link-nya buat ikut contribute untuk translation. Nanti bisa saya share slide-nya untuk teman-teman biar bisa lihat link-nya dan bisa join ke Slack channel buat tahu gimana caranya translate. Kita kebetulan lagi butuh bantuan untuk translate di glossary Kubernetes. Ini cocok banget buat first time contributor, jadi teman-teman jangan ragu buat ikutan kalau misalkan mau ikut contribute. Next, teman-teman yang punya ide dari audience atau teman-teman yang punya ide atau lagi mau hiring, bisa lihat di cari kerja.detect.id. Dan terakhir, teman-teman yang belum join ke grup Kubernetes Indonesia bisa join di Telegramnya di t.me/Kubernetes Indonesia atau di meetup.com di Jakarta/Kubernetes atau meetup.com Kubernetes Cloud Native Bandung. Ini yang Bogor karena kita udah pakai link yang Cloud Native Community, nanti bisa dilihat di slide ke-2 di presentasi ini. Dan untuk repository Cloud Native ID-nya bisa dilihat di github.com/cloudnative-id/meetup. Oke, itu aja dari Bogor hari ini. Teman-teman yang mau sampai jumpa di Cloud Native Community Meetup selanjutnya. Terima kasih.